So we have a stone that is rolling down a hill where it encounters some friction before coming to a stop. The force of the friction is 30 newtons and the velocity is 15 meters per second. What's the final position and the final momentum if it only encounters 4 seconds of friction and it takes 2 seconds to encounter the friction and the stone keeps rolling for 2 more seconds after the friction? The mass of the stone is 10 kilograms, and we know that the stone is only traveling in the x direction, therefore the normal force and the force of gravity are going to equal 0. And we know that the force of friction is going to be pointing in the opposite direction of the direction of the stone. So for our first iteration, we need to calculate the net force. And the net force is just the sum of all the forces that are acting on the stone. We know that the force of the friction is going to be 0 in this case because the stone is not encountering any friction. And we know that the normal force plus the force of gravity are both going to equal 0. So to calculate the force of gravity, we take the mass of the object times g, which is 9.8, and we get negative 98. And to get 0, we have to add 98. So we know that the normal force is going to be positive 98. And when we add all 3 forces, we get a net force of 0. So when we take the mass times the velocity, we get an initial momentum of 150 newtons. And so we take the initial velocity and we add it to the net force times the delta t, and we get a future momentum of 150 newtons. Then to get the V average, we take the future momentum divided by the mass, which gives us an average of 15 meters per second squared. Then we take the current position and we add it to V average times delta t, and we get a future position of 15 meters. Now we do the same thing and everything is going to stay the same except when we add the position, we now get a future position of 30 meters. And when the stone finally does encounter its first second of friction, we know that the force of friction is 30 newtons. And so we take the 30 newtons and add it to the 98 and then subtract the 98 to get a total net force of 30 newtons. And so we plug that into our equation, and now we get a future momentum of 180 newtons. And when we divide the future momentum by the object's mass, we get a V average of 18 meters squared. And when we plug all of these in, we now get a future position of 48 meters. And we do the same thing, and then we see that we are increasing by 18 meters. And so at the end of the 4 seconds of friction, we have now traveled 102 meters. And so for the final 2 seconds, we go back to having our F net equal 0 since there is no longer any friction being encountered, and we get a final position of 156 meters in the x direction and a final momentum of 270 newtons.